know it. It looks like this guitar amplifier. Well, it's audio amplifier, but I'm going to use it for my guitar. This audio amplifier of ours is a little bit more complicated than we'd want it to be. The reason for that is because it needs a dual rail input voltage supply, and pretty beefy one at that. It can do about 40 volts plus or minus, and I've already done the DigiKey search here. You can see down here my search terms. Current output, output configuration, voltage, output max. Output configuration was the key here, right? So when I was going through and looking under PMIC voltage regulators, DC-DC switching regulators, I changed the output configuration, filtered it by, was it dual rail? Yes. Positive and negative dual rail output. I got these chips. All of them are from Analog Devices, which is good. Analog Devices is fine. I prefer if there's a little bit of competition, but you know, sometimes you get what you get. Analog Devices does good work. Now, they do have indirect competition in the fact that you can have dual rail power supplies by just using two different power supplies, right? So I could have two chips. The thing is, I don't mind paying the $5 if it reduces my complexity. And the fact that this is already a one-stop shop package makes my life a lot easier. So here it is. If you were to turn this into a product, right, it'd be $3.57. But little secret, proper engineer who's in the commercial space, little secret between you and me, DigiKey's prices are always way inflated to what you'd pay if you were actually in production, making tens of thousands, hundreds of thousands, millions of these parts. You're going to be like looking at a lot less, probably less than half. If you work out a deal with the manufacturer, in this case, Analog Devices, okay? But that needs a lot of volume, okay? And if you're just starting out, you're probably going to be on DigiKey time. Don't do the Alibaba thing. I know it's tempting to get really low prices, but you don't know where those chips have been. The reason you pay for DigiKey is so you have a clean bill of health, a clean birth certificate, so to speak, for your chips. And if you're just starting out, you really don't want to be pissing off your customers. You're going to be living on word of mouth. You can't, even big companies cannot afford to have a lemon get shipped out. So be safe, pay the extra money. Your customers will appreciate it. Grow slow rather than die fast. All right, so here's our typical application circuit. This is a 2 amp / 1.2 amp DC-DC switching regulator. I'm guessing the 1.2 amps boost regulator. Okay, so if you're doing boost regulating, all right, so the inverting regulator is 1.2 amps. Okay, the boost regulator for the V positive is 2 amps. So you could use this to possibly power other things as well, but you're not going to be pushing a symmetrical waveform through this thing, okay? You're probably going to be limited to the 1.2 amps. They probably just put the 2 amps on there because it looks good on a data sheet, and they can pull it off. But I don't really give a lot of credit for that. Sorry. But hey, 1.2 amps is a ton of power. That's a lot. Good Lord. What was it? I mean, P equals VI, right? So if I want to take the I out of the bit, all right, so to take the V out, so V equals, all right, so that's P equals I squared. I don't memorize equations very well, so I have to just derive them in my head every time. It opens up the chance for errors, but that's errors in calculation versus error in memory corruption in the old noggin here. So it's I squared R, so 1.2 times 1.2 is 1.44, because 12 times 12 is 144. 1.44 times 8, so you're looking at 8 watts or so. I don't know. Yeah, maybe we probably can't push a ton out. We're not going to hit the 100 watts. That would require some seriously beefy power supplies that I just don't have here, but whatever. Anyways, doesn't look like a ton of components. We got inductors, diodes, resistors, a lot of capacitors. Doesn't look like it's too terribly serious. Let's see if there's a... All right. Here's our packages. We've got a quad flat pack, and we've got a T-SOP. Yep, T-SOP with an exposed pad. Okay, that exposed pad is going to be really important. That is to analog ground. That's going to help us cool down. I'm going to see if I can put this chip on the bottom side of the circuit board, and on the top side, a lot of vias between the top and the bottom, so I got good thermal coupling. And I'm going to slap a heatsink on the top, just in case. I'll have at least the option to do that. I'll probably use like silver paste or something, some sort of adhesive, to put the heatsink on. But okay, here we go. Now, what I'd like to see is some component values. That'd be nice. The only component values I was able to find in here with a preliminary search were in this table here, but that's just for the feedback resistors, right? So RFT feedback 1, yep, so you got the two. You got the two power supplies. Okie dokie. All right, 1 microfarad VREF. All right, so there might be some suggestions in here, but they're kind of buried in, right? Now, one thing I could also do is just go and find the evaluation board for this and just copy the eval board. That is a legit strategy, as long as the eval board is doing the same thing I want to do. Which, I mean, this thing is a dual rail power supply, and I don't really see how an eval board would be that different. Yeah, a lot of math involved here. If I was an engineer and I was trying to do this real proper, right? I'm an engineer who's doing this as a hobby. If I was doing this really properly, I would probably have a Excel spreadsheet that has all the stuff in it, so I can change at the drop of a hat. Oh, here we go. All right, so this is a typical 5 to plus or minus 15 application, right? Now, do they have a... What do they got here? Super low noise with optional LDOS. Okay, so what they're doing is they're taking the outputs, which is plus 16 volts, and this is almost exactly the same as the previous schematic up here. All right, so I think it's a carbon copy. And on the outputs, they're taking that 16 and they're just dropping it down to 15. And they're taking that negative 16, they're dropping it up, in this case, to negative 15. And what that does is that LDOs have a lot better regulation. They don't have as much ripple noise. They've got good ripple rejection, good line. Oh shoot, I forgot line stability. I forget what it's called. There's line and load stability, which is line is what's going, how immune are you to noise coming into the regulator, and load is how much resilience do you have to changes in load, right? If the load on your line changes a lot, okay. Okay, here's some performance. All right, so that's performance for the LDOs. Cool. I mean, that's a good thing to know. I don't think I'm going to worry about noise too much on this, but you know, if it becomes a problem, then I'm going to just be ready for a rev dash. I don't want to do a rev dash to this board, but you know, I'll do it. I'll do what I got to do, man. Cool. Suggested layout. That's really good. That's really good. All right, so you got your CN, you got your VREG. Cool. There's no reason why I wouldn't just copy this. This design looks pretty compact. I mean, it's all on the same side, so I'm sure I can get a little bit more compact, but I'm not gonna sweat it. I'd prefer better performance over better swap, which is size, weight, and I forget what A and P stand for, but you know, just size, weight, and form factor, all that crap. Don't care. Look, all right, love this. All right, they've got suggested diodes. That's what I want to know, and they've got values here on everything. This is outstanding. This is what I want, because I want to fast track this. I don't have a lot of time to spend on doing a ton of calculations. Does that make me a bad engineer? Yeah, that makes me an engineer who's doing a hobby. All right, I'm not. If I was making a real product, I wouldn't charge money for what I'm about to do. Okay, you know, this is, I would say, open source quality. This is I'm having some fun. All right, what is a Schottky? Very good. Okay, so Schottky diodes. What a Schottky diode is, has a very low forward voltage. So if you take an LED, right? You take a green LED, it's going to have like a 1.4 or something voltage drop from the anode to cathode, right? You're going to lose some voltage. That voltage just gets converted over to light, right? The voltage times the current is going to give you the actual energy output. Now, that's fine for an LED, okay, because you're trying to make light. But if you're just trying to act as a valve, you want to have as little voltage drop as possible, because if you have a voltage drop, and this thing's voltage drop is probably like, yeah, a little less than a volt is what you usually get for a forward voltage. 700 millivolts drop at 2 amps. 700 millivolts at 2 amps is 1.4 watts. That's a lot. That's a lot, right? But that's why you need the Schottky to be as low as possible. Because if it was 1.4 volt forward voltage, it wouldn't be 1.4 watts. It would be 2.8 watts. It would be a lot worse. You'd be melting your part. You'd be blowing your part up. You'd have to get a gigantic part just so you have the surface area to dissipate the heat. All right, that's a good. It's a relatively cheap diode. I mean, I've seen cheaper. Maybe I could do better than this. Let me check this out. All right, I gotta like preload DigiKey here. You know, make sure it's ready to go. Now, one of the good things about this is that the awesome guys at KiCad have a library symbol already for this part. Now, I would be lying if I told you that's not how I found this part originally. It is how I found this part originally because I'm a lazy man when I'm not being paid to do something. It just so happens that this is the only game in town, and this is exactly what you want for a monolithic dual rail voltage regulator that gets the range that I want and the current that I want. Those are the things that make me happy and are going to make this project work, okay? So I don't see any reason... All right. I'm just going to keep this thing enabled constantly. There's no reason not to. So let's get in here and do some stuff. Sorry, I'm doing some Vegas plans. Where am I? Where's the data sheet? Dadgummit. Oh, here we go. Is this the right one? This is the 7.3. I decided not to go with that one. No. Alright, I lost the window. I'm going to find it. I'm going to find you. Okay, here we go. Okay, cool. Found it. Alright. Alright, these feedback resistors are going to be different. It's going to be according to the table that's up here. This table right here. So table 8. That's where we're going to get our feedback resistors values. I'm going to use 5.9 for RFT1 and 170. That's 5.9 mega ohms and 137,000 ohms for our feedback 1. Okay, and then you can read. It's right here. Apparently I can't read out loud. Yeah. Yeah, buddy. Keep scrolling. All right. So we're just going to make this in KiCad. Easy peasy, right? They even laid it out the same, I think. So here's P ground. They took P ground, they moved it over. That's fine. I don't care. This is redundant, I think. I could put another 10. It's redundant with the capacitors I already have up here for the voltage supplies. But I tell you what, proximity matters. So I'm going to have these near this chip. So I'm just going to go ahead and redo C out 1 and C out 2. It's not a redo. Geography does make a difference on a circuit board. Even if it doesn't, it's a good practice to design safely and then just do a don't populate, DNP, do not place for components. It's better to lay out more and safer and then just not use it, right? So it's all about keeping your options open. Okay, so comp 1 has a... All right, let's do this. Comp 1's got you and you. Cool. Oops. Let me zoom in. It's an eye chart. All right, PV in, all this stuff about P's and V's and whatnots. There we go. PV in, those all just go to plus 5 volts in. That's incredible. I'm going to call this... is that all 4 of these pins? So all the PV ins are alright. And then VREG. Okay, VREG just has a bypass capacitor on it. Alright, cool. Tell you what, we're doing that. I'm doing that. We're going to do that. I'm going to place a power, and we're going to call this V... Oh no, it's doing that thing. Oh, I hate it. Okay, yeah, KiCad's doing that thing where it's launching a window in a non-existent place. So that means I got to restart KiCad. Awesome. That's all right. KiCad's a pretty lightweight software. You don't know the kind of games I have to play to get this set up to work and record. Yeah, see, this wasn't popping up. Now, maybe it would have if I had like waited a second, but I'm not about to do that. All right. I need a V unregulated input, right? So I'm going to call this V12 because I have a 12 volt 2 amp power supply over there, which I plan on using. So let's just call it, that. Not super happy with that. Let's fix that. That's better. Okay, I'll take that. Okay. Now you just have a bypass capacitor, if I recall. Oh my gosh. Oh, this placement is killing me. All right. Hate it. I hate it. Symmetry. So, when you meet an engineer and they've got like a stick up their butt, as many of us do have, ask yourself why do these engineers have a stick up their butt? That's a fair question. Like, why are they so picky about every little detail, every little placement? Why don't they just chill out, relax? 1 pixel isn't going to make a difference. And I think that comes from a place of privilege. Oh, I hate having this crossover. This sucks. I hate it. Fix it. Fix that. So ask yourself that same question. Why do militaries do the same thing? Now, I'm not saying the engineers are like on the par of military. I'm not going to be one of those guys who like, you ever meet those guys who are like all talking tough and they act like they're in the military, but they're really just some fat defense contractor who drinks tons of black coffee, and everybody knows they drink black coffee because they tell everyone they drink black coffee. Those people who just like, back in my day. It's like, yeah, back in your day, you were dodging Vietnam. I'm not impressed. Whatever, I don't care. This ain't your day, Grandpa. Sorry, I'm kind of being a jerk to boomers, but really I'm being a jerk to defense contractors, so I don't know, deal with it. Don't be such a snowflake. No, it's not an age thing, because I've seen young people do this exact same thing. It is not an age thing at all. So if you're taking it that way, I hope you don't. Because if I'm going to offend you, I want to offend you on purpose, properly. No, it's a tough guy thing, right? Now, there is a reason though why stuff is uniform for militaries, because if everything is uniformed and everything is perfectly placed, and it is the same, if your uniform is exactly the same as the person next to you, to the millimeter, the placement of your medals, the placement of your name tag, everything about it, what it says is that you're in control. And don't we want our military members to be in control? You don't want like a drunken band of like bandits, All right, Sync Freak is going down to ground. Slew and Seek doing nothing. I'll just jump you over that way. I mean, I feel a little weird doing that, but it's okay. We're going to put a big no connecto. No connecto. We got a bunch of grounds here. P ground, A ground. Got all sorts of grounds. Now notice these are 2 different grounds, okay? That's actually pretty important. So I'm going to... Oh boy. Oh boy. Oh, what do I do? It's explicitly saying there's a separation of grounds. Yeah, I think I need to do something about that. Okay. So I need to use a different ground symbol, and that is a proper thing to do. Yeah. This is going to make my design a little more complicated than I wanted, but it's going to be okay. Don't worry. Don't panic. Stop panicking. Stop panicking. And then what you do is you take your ground reference here. So I got my ref ground, and I got my signal ground, and I'm going to have them... Check this out. I'm going to grab me a 0 ohm resistor. I'm going to place it. And I'm going to make that into something else. I'm going to probably make this into just a piece of metal, like a jumper. Yeah, I'll probably turn it into a jumper, because I want to keep these grounds separate. Now, the problem is I've used the same ground symbol for the rest of the circuit. I'm going to have to replace all those, because this is now a different ground. The reason why you do this is just to keep things organized. That's it. It's ground is ground. Yes, that's true. Technically speaking, that is true. But the thing is, electricity isn't just about having a direct piece of copper. It's also the geometry of that copper. It's the signals that are being returned. Because remember, all of the voltages that are being, all of the current that's being conducted is coming back through the ground. The ground is not zero. The ground is a mirror of the power supply. The ground is just a reference. But all of the power, all of the signals, they're going through ground just like they're going through the signal wires. They need a return path. So it turns into a big problem if you don't get that straightened out. All right, rant over. Where is SS? It is also disconnected. Cool. All right, we're getting closer. So enable on. I want this just hooked up to plus 5 volts. So we're just going to grab this guy. Normally I don't like to cross over wires, but you know, if it's going to be something that's pretty clear what you're doing, then that's kind of okay. I'm going to move this 22 though. There we go. I really don't like how these feel like they're on different grids, but whatever. All right, now where's my plus 5 volts? I think I had some somewhere. I got plus switch. I guess I didn't have a plus 5 volts. Oh, there it is. Okay, there's plus 5 volts here. So I gotta also put a 5 volt regulator on here, and I don't know if I'm gonna go with a switching one, or I think I might just go with a. I think I might just go with an LDO because I'm not really putting a ton of current. I don't think this thing has a ton of quiescent consumption. Quiescent. Oh gosh, this is the. Yeah. All right, so it's like 3.5. It's milliamps. It's milliamps. All right, so quiescent means how much current is the chip itself going to consume, right? So if you say that, all right, this chip is going to be able to regulate tons of current, yeah, that's not. That's true. It's going to do like the 2 amps or the 1.2 amps. That's how much it's allowing through it. That's not how much it's consuming, though. Itself, it's going to take a little bit of a cut of that, and it's going to consume some current. That's going to be 3.5 milliamps. That's nothing. I'm not concerned about that. So that could come from an LDO. You don't want to use LDOs for high current paths. You want to use them for cheap, low current paths. You want to use them for things that need very little noise, or sorry, that aren't very noise tolerant, right? So if I've got like a signal, and I've got a chip that's listening to an electrical signal real closely, I don't want to use a switching regulator for that, because the switching regulator is gonna it's like you're listening to a phone, and then there's a buzzing on the phone. I'm listening for tiny little details on the other end of that phone, and if I got a constant buzzing on the line, it's just no good. All right, so. All right, I got that. I didn't give you a bypass. No, I did give you a. I did not give him a bypass capacitor. Holy crap. Okay. I tell you what, though, this is kind of messy in here. I like to take my bypass capacitors and I don't know. It's right there, though. Shit. Yeah. Man. Let me think. I can make this work. All right. Watch me do it. Retraction alpaca. That's pretty catchy. I know it's supposed to be for a. All right, how many micros? That's 10. All right, 10 I can do. Once you start getting to 22 microfarads, I mean, depending on the voltage level, the capacitor can get kind of difficult. Oh, I don't like that, but I'll deal with it. I'm gonna grab you, Mr. Ground, and just put you right over there. How about that? Holy. This is dumb. I did a dumb thing. Kill it. Kill it with fire. There we go. Now, I haven't... Notice I'm not assigning values to any of these yet, because I'm just not there yet. I'm just not at that point in the process. I think this is understandable. It's not the most aesthetically pleasing, but I'll deal with it for now. I'll fix it later. Alright, so I got my 12-volt supply. 12 volts going in, got my bypass. VREG has its bypass. Boom, bypass to ground. Very cool. All right. We've got enable is going to plus 5 volts. Very cool. All right. Comp 2 is good. Sync freak is good. Very cool. Everything's good. Let's do the other side now. All right, so I need an inductor. That's going to be in placement, symbols, and it's going to be under devices, or sorry, device, and then it'll be inductor. Was it just L? Oh, okay. It's also under the symbol just L. All right, now how'd that go? That went between in BK and switch 1. Okay. So here's in BK, and there's switch 1. So I'm going to do it like this. Since I don't have a lot of vertical space for this, I'm going to do it like that. All right, then we got a diode. I'm going to do the same thing. I'm going to grab a Schottky. Schottky. All right, Schottky's out. I want it to go, well, let's keep it up here. All right, so Schottky out. Resistor back into feedback 1. All right. Let's roll with that. Now, it does seem like I'm a stickler when it comes to aesthetics, and that is true. That is true. You could technically make this as ugly as you want, as long as the wires are going to where they need to go, then you're fine, right? The problem is I've sat and had to look at schematics for hours and hours for a day. The aesthetics start to matter. I did a video, a Thinking Out Loud video on this a while ago about how humans have an innate aesthetics like instinct, and what the aesthetics do is we like regular simple patterns. We like things that are, we kind of either like things that are photorealistic, like look really realistic, or we like things that are really simple. You'll notice how cartoons aren't, like popular cartoons are not anywhere in between. They're either very realistic or they're very symbolic. I guess cartoons is a bad example because they're always just symbolic, but just any media. Like, we want a video game that's either super realistic or it's very cartoony and stylized, right? And there's a reason for that. We have a natural love of all things aesthetic because they're simple. They're representatives. Whoa, I don't want to do that. I just want to do this. Okay, I don't want to duplicate. Yeah, man. So notice how I tend to leverage the copy pasting. First off, that reduces on errors. You don't want to open yourself up to making errors. We call them typographical errors if it's just you putting in the data. All right? If it's like you entered a word in twice or something, or you put, two components on top of each other, which can happen. I can see that happening. Let me move this guy up a little bit. Give some space there. Get a little breathing room here for this. Can I do that same thing here? Nope. Okay. Okay, we got, now it just goes to the output, and the output is bypassed to P ground. Okay. And that's it. Oh, wait. Whoops. I did a copy. All right, let me check over this. All right, so VREF inductively fed into FB2. VREF is, yeah, okay, this is not correct. This is absolutely, I can't copy any of that, actually. Just forget it. Now, if you could, that'd be great. But in that case, you can't. All right, so switch 2 is actually getting shunted. If this was like a dual output positive supply, then you could do that. But I'm a big dummy, and I tried to be clever. Sometimes being clever pays off. More often than not, being clever actually gets you destroyed. The good kind of clever is when you make things simple. Simple is good. Simple is easy to understand. Simple is easy to check for mistakes, by the way. Life and success is not about being right. It's about being able to verify whether or not you were wrong. Being able to verify whether or not you've made a mistake. Okay. This is looking like a mess. I mean, it kind of is a mess, to be honest. All right, so diode anode is resistive feedback into FB. Okay, so that's what this is here. And then we have a resistor up to VREF. Woof, 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 woof. This is a mess. Okay, I think that satisfies. So VREF. Okay. And now I just need to put a bypass capacitor on that line. Ugh. So ugly. Oh, your circuit's so ugly. That's all right. We're gonna make it better, okay? Whew. Hot dog. Just drag this stuff up. By the way, I use G for all this dragging. Okay, so just pretend all the letters and numbers aren't there. That looks okay. That's not the worst. Alright, I could have done worse. Let's just double check it. Sorry, so VREF resistor back to FP2. VREF resistor back to FP2. Now FP2 resistor over to the diode, cathode, or anode. Okay. Diode cathode to an inductor and switch 2, and it's down to ground. Okay. And I'm just going to go ahead and put these oh, you know what? I have a chance. I got a chance for beautiful symmetry. Watch this. Watch this. Okay. I wonder if I can make this work. You see what I'm trying to do, I think. Alright, whatever. Let's try it out. Let's not poo-poo it in my own head. Let's see how it looks on paper. Okay. Alright. Oh man, if this is just one more pip up, I could make this. Nah. I actually need 2 pips to do it. Alright, so we got some ugliness, but at the end of the day, it's looking like it's not the worst thing in the world. Okay, cool. Now I just need to grab my voltage nets, VSW plus, okay, and VSW minus. The name of these specifically doesn't matter, it's just the fact that it's the consistent. So once you pick a name, just roll with it, go with it. I'm also going to move this over to the right. Now I could spread this whole thing out a little bit and probably give it some breathing room. It'll look a lot better, and I probably will. But so far, this is not the worst thing in the world. It is a little bit of an abomination. I'm not gonna lie. I'm not the happiest I could be with it, but I think it'll do the job. I'm just very carefully now just dragging things over because this could turn into a nuclear mess in a minute if I don't do it right. Okay. 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 We like right angles and schematics. You leave that 45-degree nonsense to your layout. Alright, yeah, this is fun being able to steal a couple of minutes to do this design here with you guys. This is pretty fun. I mean, it is for me. It's not the best. I mean, I'm a weird dude, so I'd totally watch someone doing this for hours. That's kind of just a relaxing way to just spend the afternoon. Let's go ahead and fix the problems that we made, though. All right, because we've done some goofery with these grounds, because these grounds are no longer that ground. Actually, I think it's okay to leave the signal grounds over here. Anything that's power, though, I think needs to get moved over. Yeah, so all signals need to. Yeah, all the signals for the audio need to go have a consistent ground, or we're gonna have a lot of trouble. So, I'm sure an analog engineer, if they were watching me, they'd be absolutely infuriated by what I'm doing. I mean, mostly because engineers are infuriated by anything anybody does. It's kind of hard not to infuriate them. We're a pretty incendiary crowd. Okay, cool. Yeah. All right, cool. Yeah. Yeah, and this will just be a jumper. I'm not gonna stress too much on that. Now this thing is a hot mess and it is broken. Let me fix it. That's what I'm here for. That's what I get paid to do. Okay, we're making things happen. Well, this is a tight one. I don't like this. But it'll work out. It's going to be a squinter, but woof, I don't like that. I don't like it, but there's nothing I can do. I mean, you're not going to like everything that you do. There's always going to be something wrong with it. It is what it is. I also don't like turning my head when I'm reading. If I can, every single one of these letters is going to be in the same orientation. It's not cute. It's not fun for whoever has to read this thing. It's just absolutely infuriating. Okay. So all I need now is a 5-volt regulator. I don't see a reason why I can't just use a 7805. 7805. Yes, it's like a 7805 is just what you use, man. And what we're going to do is we're going to grab this exact same... Like, look how simple the 7805 is. It's just absolutely simple. And it's got like a 10 microfarad on the input and like a 1 micro on the output. It's the same kind of thing you always see. I'm going to give it the signal ground because it is the ground for the signal. I don't usually like doing this weird symmetric thing I'm doing with it though. I like to stick ground to one end or the other. So let's do that. Man, I gotta make things difficult for me, okay? Alright. Okay. Now that same 12 volts, this 12 volts is our input voltage for the circuit, so heed that. Alright. That's gonna go to our 5 volts. See how easy that was? See, contrast the level of ease and complication. What we just did. All right, now I'm going to leave it as a to-do to go ahead and assign all the values. That's just paperwork. I'll do that on my own. But you've just watched me make a full thing over here, you know. And I always print these out, and I sit with a data sheet and I double check the pinouts because I don't trust it. I'm going to verify it. Assign the values, all that stuff, all that good stuff. Also, I probably should go ahead and place a symbol here. I need a connector. Now there was a better connector library actually down here. Get out of here. Yeah, connector generic. That's what you want. All right. Okay. This connector is how we're going to get our 12 volts and our ground in. And I'm going to assign that a footprint later. So we're going to have a terminal block probably where our 12 volts is coming in. From that, 12 volts gets converted to 5 volts here. 12 volts also gets converted to plus or minus VSW. Plus or minus VSW, as well as the 5 volts are going to go into this chip. The 5 volts in the form of mute and standby signals, and the VSW and negative VSW are going to be the positive and negative voltage rails for this. So this is a great project for that. And we've got our speaker here. So all this circuit was good. I checked it yesterday. I'm going to do a final check, and I'm going to go ahead and assign values to all this stuff. We've got our ground bridge here, which we're going to locate strategically to reduce noise as much as possible. That's going to be a tough one. I need to figure out where I want to place it. Like, do I want to place this right between the two chips? Because it's natural that you have two different chips here, right? So do I place it towards the power supply, or do I place it towards the client? The client chip being the TDA 7293, you know? I don't know. You know what would be a real cheeky thing for me to... Oh, that's a cheeky thing for me to do. I'm just going to make two of these, and I'll just solder whichever one works out for me. So if I like have a bunch of noise, there we go. If I have a bunch of noise, I'll solder one, then I'll be like, oh, all right, well, I'm going to go ahead and unsolder that and try the other one now. There we go. Boom. Done. Don't like give yourself as many options as you can, man. Don't like paint yourself into a corner. If you're not sure what to do them both. It's a circuit board. It's like an extra square. It's like an extra, 5 square millimeters for another jumper. It's not a big deal. All right, I like it. I love it. And takes me a while to work OBS Studio. I had a lot of fun just now. It's kind of fun just watching people work, do their job, you know? It's like watching a blacksmith, except I'm not smashing stuff with a hammer. I'm just smashing my head against this desk, yammering to you constantly, reading data sheets, and just saying, I don't know what this is, and I don't know what that is. That's pretty much what engineering is like these days. If you enjoyed it, hit subscribe. If you liked it, hit like. If you want to comment and hear more about circuits and see what I'm doing, if you have any requests of circuits you'd like me to make, make a comment. What's the worst that can happen? I just ignore you, which is, what I was doing before I even noticed you were alive. So, nothing ventured, nothing gained. I'll see you guys later, and have a great day.